Hello learners, this is Akash. I completed my BTech from NIT Rourkela in the year 2020. Currently I am a mathematics teacher. Now let us see how to solve this given integral. I know this is a little tough. I'm gonna go a bit slow. In case if you feel my video speed is, my explanation is too slow, you can increase this video speed to 1.2 or 1.5 as per your wish. Okay. Now here we need to solve integral 6x plus 5 under root 6 minus 2x square plus x dx. Okay, a little tough one, I admit. Stay alert and stay attentive. So the first step is we have to write 6x plus 5 as a into derivative of the 6 minus 2x square plus x plus b. This is the first step. Now what would we get by writing this? You will understand as we proceed why we are doing this. Okay, now derivative of 6 is a constant, so its derivative is 0. Derivative of minus 2x square. Now listen, minus 2 is a constant, you need to know, now x square, what is derivative of x square? Derivative of x square is 2x, so minus 2 into 2x would be minus 4x, so I'd get a into minus 4x. And what is derivative of x? Derivative of x is nothing but 1, so that's why I have plus 1 here, and then plus b. Just mark it as 1 because we are going to use it a bit later. Okay, now next just multiply minus 4ax plus a plus b. Okay, now beside x I have minus 4a, here I have 6. So on comparing the coefficients of x and constants, this is what I would get. Minus 4a is equal to 6 and a plus b is nothing but 5. Let us first find out a, which is actually a bit easy. So minus 4a equal to 6, so a is nothing but 6 by minus 4, which is nothing but minus 3 by 2. I just took the minus to the top, that's all. Now next, a plus b is 5, right? We already know what a is, so put that. Minus 3 by 2 plus b is nothing but equal to 5. So send this minus 3 by 2 to the RHS. I'd get b is nothing but 3 by 2 plus 5, or 5 plus 3 by 2, anything. Now just take LCM. 5 2s are 10 plus 3 by 2, so 13 by 2. Okay, now we got a and b. Okay, now what I'm going to do is I'm going to put these values in 1, where in this first equation I marked it as 1, right? Okay, so from 1, 6x plus 5 is nothing but minus 3 by, see, a is minus 3 by 2 and b is 13 by 2, so minus 3 by 2 into this derivative of this plus 13 by 2. This is what I get. Now we are done with our foundation work. Now it's time to start building. Now this is what we need to find out. This was just a starter. This is the main dish which we need to finish. Okay, this was just a starter. Fine. Okay, so now 6x plus 5, we can write it as this. That's what we got, right? So in place of, in this integral, in place of 6x plus 5, write this. Okay, minus 3 by 2 derivative of 6 minus 2x square plus x plus 13 by 2, and then this is there under root 6 minus 2x square plus x dx. Okay, now what I'm going to do is I'm going to expand the first bracket, this bracket. Fine. So minus 3 by 2 derivative of this into this dx. Fine. Okay, so that would be 1, and I'm going to integrate them separately, so integral also would be 9, and then plus 13 by 2 into root of 6 minus 2x square plus x dx. Okay, fine. As I mentioned, so minus, it's pretty simple to understand this step. Okay, I'm going once again. See, minus 3 by 2 derivative of this would also be there, and integral comes here, and then again 13 by 2 is there, 13 by 2 into this, and then integral is there. I'm integrating them separately. Okay, now minus 3 by 2 and 13 by 2, they are constants, so we can just write them outside the integral. Minus 3 by 2 into integral of this plus 13 by 2 integral of this. Okay, now it is my sincere advice, do not integrate these two simultaneously. Take the first integral as I1 and the second integral as I2. In the end we can just do I1 plus I2, because first thing integrating them simultaneously stuff. And also it would be a bit big to write it also. The length of each step would be a bit more, so it's better if you can follow my advice. Okay, fine. And I know you might be more bored at this point. Oh my gosh, what is going on? But in case if you want to learn this integration, learn this topic, learn this concept, please give me your focus. Okay, sure, please give me your attention. For now, take this as I1. This I'm taking as I1. Next, you will see that this would be my I2, and ultimately I1 plus I2. I'm gonna, just do. I1 is this. Now, in indefinite integration, there is a very nice, property. It states that. I mean, it's a formula also. You could say integral root f of x into f dash of x dx is nothing but 2 by 3 f of x power 3 beta. Now, plus constant. Now, you might think, why is this do? What is this doing here? This has very much to do with regard to what we are doing here. See, we have root of 6 minus 2x square plus x, means root of a function, root of f of x into derivative of that function. You see, it's matching root of that, and then derivative is same. So likewise, root of a function into f dash of x means derivative of the function is nothing but the answer is what, 2 by 3 f of x power 3 by 2 plus constant. So here my f of x is this 6 minus 2x square plus x. Okay, fine. And then minus 3, since minus 3 by 2 is there, so minus 3 by 2 into 2 by 3 into that 6 minus 2x square plus x whole power 3 by 2 plus constant. I'm taking it as c1 because I took my integral as I1, so I'm putting my constant as c1. Fine, so 2 cancel, 3 cancel, minus is there, minus of this plus c1. Okay, we are done with the first integral I1. Now I2. This is a little tough. From this is where things get a bit tough. So please stay on your toes. Please stay alert. Now what I'm going to do is, first we need to write this 6 minus 2x square plus x has a perfect square plus another perfect square. Now how I'm going to do it is, stay tuned. So first, this is like 6 minus 2x square plus x, right? So minus 2x square, write it in the beginning like x square and then x term and then constant. So and then plus x, right? And now I want to make the coefficient of x square 1. For that, what I'm doing is I'm going to take minus 2. See, here I have minus 2 beside x square. What I'm going to do is I'm going to take minus 2 common from the 3 terms. Take minus 2 common from the 3 terms. Now, what would happen if I were to do that? Don't get confused. See, whenever I'll take a minus common, the sign changes. So this was initially minus. Since I took minus common, it became plus. Here there was a plus minus, plus minus. Okay, so simple thing. Now next, I took 2 common. I also took 2 common. So 2 I took common. So x square is just like there. But you see, this x doesn't have any 2 to give. So you can like imagine there is 2 by 2. So 1 2 came out. Numerator 2 came out. Denominator 2 is there. So x by 2. In from this 6 you can just take out 2. 6 can be written as 2 into 3. So when 2 is taken out, 3 is left. So this explains this thing. Now you might think, why I'm doing this. You'll understand why I'm doing this. I want to apply some formula. I'm taking this, I'm converting, I'm rearranging the things so that rearranging and modifying things so that I can apply that formula. Now multiply and divide by 2 here. Why means so that I could write it as 2 into x into something. So this I can write it as 2 into x into 1 by 4. Now if you observe the first two terms, this is something like a minus b whole square. Okay, I mean there's something like a minus b whole square. Don't you think so? Actually this is something like a square minus 2ab. I'm sorry, I told some a minus b whole square came out by mistake. There's something like a square minus 2ab. There's something like a square minus 2ab. A square minus 2ab. Now how can I make this a perfect square? I need plus b square. So basically I'm going to add b square and I want to subtract b square so that I can make the first 3 terms as a minus b whole square, and I'm left out with minus b square. So here my b is 1 by 4, so add and subtract 1 by 4 square in this bracket which you see. So 1 by 4 whole square, so these three terms, the first three terms, they will give x minus 1 by 4 whole square. They will give 1 x minus 1 by 4 whole square, and then this is minus 1 by 16. Okay, fine. Chalo, now just take LCM here. So minus 1 minus 16 3s are 48, so minus 1 minus 48 by 16. I wrote both minus in a bracket, that's why in between I kept a plus. Now minus 1 minus 48 is minus 49, plus of minus 49 is, minus 49 by 16 is nothing but minus 49 by 16 is what I get. Okay, fine. Now next. You see here there is a minus outside. Now take it inside the bracket. So whichever is plus will become a minus, whichever is minus will become plus. So if once minus goes inside, okay, I didn't do that first. What I did is write this 49 by 16 as 7 by 4 whole square. Okay, so hence I would get this 7 by 4 whole square minus x minus 1 by 4 whole square. So I took the minus inside, that's all. That's why minus 1 by 4 whole square. Okay, once again I'm sorry, I made another mistake. I told you guys in the beginning, right? I would write this something like a perfect square plus another perfect square. Actually it came out like perfect square minus perfect square. Okay, so sorry for that. Okay, but the concept you got right. Basically we are gonna get perfect squares. That's the concept. Right? Chalo, now let's come to our integral. If you guys remember, this is my integral. This is my integral. Okay, so this 6 minus 2x square plus x, I wrote it as this, right? So my integral won't be nothing but this 13 by 2 under root, in place of that which was there in the root, in place of that I got this. Now this root, inside this root there is 2. Okay, so the root 2 you can just bring it outside. The root 2 you can just bring it outside. So this is what. Now if you see this integral is of the form, under root a square minus x square, under root a square minus x square. So a is 7 by 4 and in place of x I have x minus 1 by 4 here. Fine. So what is the formula? Don't get afraid upon seeing what is there in front of you right now. Okay, I can see, I think I can imagine your expressions like, okay, what are these many brackets doing here? Why, how in the world these many brackets came, and why in the world these many brackets are there in this? Such thoughts could be going in your mind right now, but stay calm. It's pretty simple. I'll try my best to make it as simple as possible for you. Now see, integral under root a square minus x square is nothing but x root a square minus x square by 2 plus a square by 2 sin inverse x by a plus constant. Okay, now if you see this integral is exactly matching with this. So under root of 7 by 4 whole square minus of x minus 1 by 4. So my a is 7 by 4 and in place of x I have x minus 1 by 4. Okay, now come to the RHS. Now see, x root a square minus x square by 2. So what does it mean? So basically half into x into under root a square minus x square. So half is here. In place of x I have x minus 1 by 4. Under root of a square minus x square means just write down this as it is. Okay. This might look a bit complicated, but it's not as complicated as you might feel. Plus a square by 2 is nothing but half into a square into sin inverse x by. So half into a square is 7 by 4 whole square. Sin inverse x by x, in place of x I have x minus 1 by 4 and here I have 7 by 4. Okay, fine. Now listen, let me just show you this step and then I'll tell you what all I want to see. Now what all I've done for the next step is, what all I've done is just take LCM here, so 4x minus 1 by 4 I'd get, and there is a 2 also here, so we'll get multiply. Okay, I'll just show it. See what I get is, if basically I'm left out with half, and if I'll take LCM here, 4x minus 1 by 4. Okay, now 2 into 4 is 8, so 4x minus 1 by 8 I get. So that's why I have 4x minus 1 by 8 in place of the product of these two. Okay, next, this is there as it is, the square root term. Next, now 7 square is 49, 4 square is 16, and there is a 2, so 2 into 16 is 32, so 49 by 32. Sine inverse. Now what does this give? What does this give? If you take LCM, instead of in the back, I'm sorry, I fumbled a bit. I'm explaining about the term in the bracket. So if I take LCM, I'd get 4x minus 1 by 4. Okay, let me just erase this. I'd get 4x minus 1 by 4 in the numerator, and denominator I have 7 by 4. So this 4 and this 4 they'll cancel out, so I'm left out with 4x minus 1 by 7. That's why I have sine inverse of 4x minus 1 by 7. Okay, I hope things are clear for this step. No. Next step is I'm just multiplying this 13 root 2 by 2 to these two terms. And okay, just one thing I forgot to tell, the integration constant I took it as plus c2, okay, because my integral is I2, I am taking it as c2. Okay, now see, now listen, when I multiply this, how I am multiplying, this is another crucial step, listen to me carefully. Now 13 into this, 13 root 2 by 2 into this first term, okay, now listen how it's going is, so 13 into 4x minus 1 by 2 into 8 is 16. Okay, now what about this root 2? Where did this root 2 go? Where did this root 2 go? This root 2 went here. So and root 2 into this is nothing but under root of 2 into this side. I just took the 2 inside. Now you might ask me why. There is a reason. I'll tell you. There is a reason. Okay. Now next. Now 13 root 2 by 2 into this second. So 13 into 49 is nothing but 637. Root 2 is also there as it is. 2 into 32 I wrote it as 32 into 2. And then sine inverse 4x minus 1 by 7 plus c2. Now if you guys remember, we had to integrate this. So this came out to be like this integral plus this integral. Okay, this integral plus this integral. So basically I took this as I1, I took this as I2. So my final answer, this integral is nothing but I1 plus I2. It's nothing but I1 plus I2. Great guys, like I'm happy that you're here up till now. The fact that you're here you're listening to me right now, this means that you are studious and you are, you know, interested in getting some good marks and you're interested in learning the concept. So thank you very much. Just a little more, we are almost done. This taking more time because the reason that I'm matching this answer, I want to match this answer to the exact answer that is given in the textbook. That's why, you know. Fine. Now this integral is nothing but I1 plus I2, as I mentioned. I1 is this, I2 is this. Okay. Oh, sorry, a plus is missing. Okay, typing mistake. I hope you guys will forgive me. Next. Now listen to me carefully. This I wrote it as 13 by 16 into 4x minus 1, 6 root 2x, I mean under root 6 minus 2x square plus x. Okay, and then now listen here, listen, root 2 by 2. Okay, 637 by 32 is as it is. Root 2 by 2 is nothing but root 2 by 2 is nothing but, I'll show you, this one, root 2 by 2, right, is nothing but root 2 by root 2 can be written as root 2 whole square. So I'd get 1 by root 2. So ultimately in the denominator, so root 2 ones are root 2. So okay, you're getting right. 2 can be written as root 2 whole square and 1 root 2, they'll get cancelled. Ultimately I'll get root 2 in the denominator. Okay, fine. So and also this one, c1 plus c2. Okay, there are two constants. We integrated separately, so we got two constants. c1 plus c2, we can just take it as a one constant plus c. Okay, this is the exact answer that is there in the Max 2B textbook. This is, I think, of I don't remember the exact exercise from which this is. You can just check out. I just checked the answer and I made the PowerPoint as per that, so that the answer which is there on this on the screen which you're seeing, it exactly matches with the answer that is there in the textbook. It took me some good amount of effort to make this PowerPoint. But if you guys understand the concept and you're happy, then it is worth it, I feel. Okay, hope to get some good comments for this. I know I fumbled a little and I made some mistakes in this video. I'm sorry for that. But still, despite all that, I feel I went slowly in a reasonable manner so that you can understand this question nicely. Right? In case you like this video, please hit the like button. It would encourage me to make many more of such videos. And if this is your first time coming across to my channel, please do subscribe to it. Thank you.